Hello, this is Tanisha and this is Milestone 3 on my object detection with TensorFlow and Raspberry Pi project. Before I could start my modifications, I first needed to understand how the program works. I analyzed both detect.py and utils.py, writing notes for each line. This program used OpenCV, a library of Python bindings designed to solve computer vision problems, and tflight, a common library for machine learning model types. It first runs interference on the images the camera captures. Using the calculations of the frames per second, it takes the video input and applies visualization parameters from utils.py. This initializes the red boxes over each object, marking it with the label and a confidence marker. Anything below a 0.3 gets ignored. The capture video feed gets converted from a BGR to an RGB, which creates a TensorFlow object. Once this is all set, the object detection is applied. To gain a first-hand understanding of how the code works, my goal was to connect a simple command of printing a statement to the program. If an object is detected, then print found. In utils.py, in the visualize function, I used a variable called category name which had the name of the object detected. To stop the repetition, I used a flag. Originally set as false, once the object is detected, the flag changes to true, and the if statement no longer applies. In addition, I could only use category name in utils.py. Fortunately, with the help of my instructor, I was able to fix this by transferring the code, assigning category name to detect.py. Once I figured out the code, it was time for modifications. The first being to capture an image when a certain object is detected. I started with the same base code from the previous task, adding a line dictating to take the picture and save it to the desktop. I integrated this code into detect.py by using a flag. Capture image is set as false originally. However, once a certain object is found and capture image is false, then a picture is taken and capture image is set to true to prevent repetition. In addition, once an object is found and the picture is taken, it saves it to an individual file. The next step was connecting the servo to the program. If the object detects the desired object, it will move to a certain degree. I initially used a more basic method of controlling the servo, programming it to move to the minimum, middle, and maximum values it could turn to. However, when I attempted to integrate this into detect.py, there was excessive servo jitter. I learned that changing the pin factor was a solution to this and attempted different versions to find which worked best. This seemed to be pigpio. However, there was still significant servo jitter. To fix this, rather than specifying degree, I used pulses. After setting it using the terminal, the code was successful. With both the picture and servo modifications to the code, as well as making the setup more presentable, the project was finally complete. I used two objects for this example, an orange and a banana. Depending on which object was detected, the servo motor will point to that label marking it. For example, if an orange is detected, the arrow will point to the orange label. If a banana is detected, the arrow will point to the banana label. Once an object is detected and the servo motor moves the arrow to point to the label, an image of the detected object is saved to the file for both the orange and the banana.